Hi, Chris Kuzmal here. We're now going to be implementing insert for binary search trees. And the method that does insertion is right here on line 9. And it's there, but I'm going to actually retype it and then describe it as the insert method. Right now, we pass 9 tests, and we're going to actually create 1 or 2 problems in this sequence that I hope are instructive. So I'm going to create my method, my insert method, public void insert, and I'm going to insert a node, and it's going to be called a new node. Now, what I'm typing here on line 18 is going to be virtually identical to what I'm typing 9 lines earlier. In fact, let's make it 10 lines earlier so we can say 19 or 9. Line 19 is the same as line 9. Okay, and the first thing I'm going to do is I'm going to create a new, well, not so much a new node, a node with a name called new parent. And it's going to come from within the tree through the method called findInsertionNode. This is a method that we implemented and tested before, and it's written, that method is defined right here. Okay, and what it does is for the new node, we get its key and then use that key to find where that new node's parent is, or to find the parent of that new node within the current tree. And so we did that in previous videos. And so findInsertionNode does that. Corman Lizason and Revest put the code for findInsertion code as the first half of the insert method, and I think that adds complexity to that method that we're managing by creating this helper method. And so the rest of the insertion method is now right here. And so we'll copy line 11. Whoa. Okay. Copying line 11 asks us whether or not the new parent is null, because one possibility is that the tree is empty at the point we do an insertion, in which case the new parent has to be null because there's no nodes within the tree at all. And so ideally findInsertionNode in that case will return null. Okay, well, if that's the case, then the root of the tree will be assigned to be what the new node is. Okay. Otherwise, we do the code that's here. So we'll take all of this code and we'll describe it after we indent it properly. Sometimes copying and pasting messes up your indentation. So if the new parent is not null, then there's 2 possibilities. One is that the key for the new parent is less than the key for the new node. And that means that's as if the new node, when it were to be searched for or inserted, is going to go to the left because less is left in our convention. And that means that we set the left child of the new parent to be what the new node is. And the only difference in the else is that we set the left child instead. Oh, in fact, I have a typo here. It says set left child. If that should be set right, set our child. Okay, so I'm going to fix that little typo. And now, of course, well, not of course, but we have an error here. Insert has already been defined. What? If you'll recall, we actually implemented a version of insert based on treating the binary search tree as if it was a linked list. And we replaced next with set left child. Okay, so we will call this old, we'll change the name of this to old insert. Okay, so now we have 3 methods with the word insert: old insert, new insert, and just insert. And new insert and insert now are the same. So this means, oh, well, let's run it, run the code. We're not invoking, well, we are invoking insert. We haven't written any tests for insert. We haven't written any new tests for insert, okay? But when we run the code, we're going to get an error. And the error, which it's not very verbose, but the error is connected to the fact that the old insert always set the left child, but that's not necessarily correct for a binary search tree. So this test failure is actually a correct failure. We've discovered a flaw in our previous tests.